Hi guys, today we are going to be talking about how to graph the equation of a line. We are going to discuss three different ways to graph the equation of a line. We're going to discuss each technique in its own video to minimize the length. Cool. But before we do, let's talk about the different ways that we can write the equation. Let's go ahead talk about the different ways that we can write the equation of a line. So one way to write the equation of a line is standard form. Another way to write the equation of a line is slope-intercept form, and the third and final way to write the equation of a line is in point-slope form, and we will address that in each video one at a time. So let's open it up with standard form. So an equation is said to be in standard form if it looks like this: ax plus by equals c. What this is saying is the standard way to write an equation is fix it so you have variables on one side, constant on the other, and although it doesn't say it, it's implied that you don't have fractions or decimals. Cool. So now the next question is what is the graph of an equation? Well, let's go back to ordered pair. Okay, the graph of an ordered pair is a point. You graph it wherever you have to. But the graph of an equation, whether we have both variables or just one of the two variables, is going to be a line. Okay, so in this video, we will be graphing linear equations by using a table of values. So we are going to do a table of values to help us organize, find ordered pair solutions. So let's go ahead, open it up with fun problem A. So we are asked to graph this bad boy. So we have negative 3y plus 2x equals 3. The recommendation is to go ahead, solve for the variable y, so that way we can have nice points. That way we can have integer coordinates. So let me put a little love note to myself. Let's go ahead, solve for y. Cool. Now the question is, do we really have to solve for y? What if I wanted to solve for x? You can totally solve for x, but for reasons that will be explained in a later segment, we usually solve for y. Okay, so work your magic, isolate the y term. Let's go ahead, subtract 2x from both sides. When we do that, will leave us with negative 3y is equal to negative 2x plus 3. To isolate the y, to get rid of the times negative 3, let's go ahead, divide both sides by negative 3. And that will leave us with y equals, quotient of 2 and 3 is already simplified, but two negative numbers, quotient of two negative numbers will give us a positive number. And although you can leave this as 2x divided by 3, I recommend that you write it as fraction times x. That way the coefficient on x is highlighted. For reasons that we'll explain later why. Okay, so we have y equals 2/3 x minus 1. Fantastic. So now what are we gonna do? We're gonna go ahead use a table of values. To be more specific, table of x, and we're gonna use an xy table to help us organize finding ordered pair solutions. So in this case, we are gonna pick any value of x. In this case, we are limited to the graph space, so we can pick any x value from negative 5 to positive 5. But I'm not an overachiever, so whenever possible, I try to stick with the smallest number possible. So you guessed it, we're gonna pick 0. So when x is 0, I want to know what's the value of y. And I know you can do this in your head, but I can't, so I'm gonna show my work. So that will give us 2/3 times 0 minus 1. So product of 2/3 and 0 is 0, and that will leave us with negative 1. So the first ordered pair solution that we have is 0, negative 1. Let's go ahead, graph that with confidence. So we stay put, and then we go 1 unit down. Now we need at least 2 points to draw the graph of a line, 3 if we wanted to check it. Okay, so now after 0, 1 is my next favorite number, but the reason why I'm not gonna pick 1 is because of what I'm multiplying the x by. Now if I pick 1 for x, that will leave us with 2/3 times 1, which is 2/3, and I'm really trying to avoid fraction computations unless I really have to. So then my next favorite number will be 2, but it's the same speech. If we pick a 2 for x, 2 times 2/3, another fraction. So the recommendation is that you pick multiples of 3. So like 3, 6, 9, and its opposites, negative 3, negative 6, negative 9. So let's go ahead, pick 3. So if x is 3, I want to know what is the value of y. So we have y equals 2/3 times whatever x you chose less 1. And the question is, what if we pick different x values? You know what? It doesn't matter. Like if our math is correct, if our arithmetic is correct, when we line up our graphs on top of each other, we should get the same exact graph, or they should overlap. All right, coming back to the problem. Quotient of 3 in itself will give us 1, or we say it cancels, and that will leave us with 2 less 1 or 1. So another ordered pair solution will be 3, 1. So let's go ahead and locate this. From the origin, we're gonna stay, we're gonna go 3 right, and then 1 unit up. So again, to draw the graph of a line, we need 2 points. We got 2, so let's go ahead connect them so we can move on. What I ask my students is to please use a straight edge. It would be nice if we had straight lines. Okay, I think that's okay. And then we put arrows at both ends to let the reader know that the line doesn't stop just where we lifted our pencil. You know, it keeps going forever in each direction. All right, so that is the first problem out of how many? 3. Yeah, exactly. Let's go ahead and do this. So problem B. So, problem B. So as you can see, problem B does not have both problem B does not have both x and y variables, unlike our first problem, but that's okay. So in our first problem, we solved for y because I said so, but no, it's because of a technique that we will do in a later unit. In this case, I want to solve for y, but as you can see, it's not happening. If we don't have a variable, we can't force it. If you don't have both x and y variables, then what I need you to do is solve for the only variable that you see. In this case, let's go ahead solve for x. So let's go ahead speak to ourselves. Solve for x. Oh, these love notes are so exciting. Okay, so when we isolate the x, give me a sec. Oops, you didn't see that. Okay, let's go ahead work our magic to isolate the x. We'll subtract 1 from both sides. That will leave us with 2x is equal to 5. Excuse me. We take our time, divide both sides by 2, and that will leave us with x equals 5 halves, or 2.5, or 2.5. Whatever suits you. It doesn't really matter. Okay, so it would be nice if I can just look at this and be like, bam, this is the graph. But I'm a little rusty, so I'm going to show some work. Let's go ahead and construct a table of values so we can organize ordered pair solutions. Now, for this equation, bear in mind that we don't have both x and y variables. Our equation, well, I'm gonna look at the bottom one. Our equation reads that x equals 2.5. So no matter where I am on the line, x has to equal 2.5. So let me go ahead speak to myself again. So x has to equal 2.5. So if x has to equal 2.5, there's no way around it. We're gonna have to pick random values of y. What's my favorite y value? You guessed it, 0. When y is 0, the procedure says substitute a 0 for y and then solve for x. But there's no y, and guess what? X is still 2.5. So that's going to be our first ordered pair solution. So let's go ahead graph it with confidence. So from the origin, we're going to go 2.5 to the right and then 0 units up. So pretty much 2.5 to the right and then stay put. Let's go ahead find another ordered pair solution. What's my next favorite y value? You read my mind again. 1. So when y is 1, procedure says substitute a 1 for y and then solve for x. But again, there is no y and x is still 2.5. So another ordered pair solution, or another point that should be on the graph, is 2.5 comma 1. So from the origin, we go 2.5 to the right and then 1 unit up. I don't want to be an overachiever. If I just need a minimum of 2 points to do the graph of a line, that's it. I've shown enough work. So let's go ahead, take our straight edge and connect the points. All right. Fantastic. All right, so that's the second out of the third problem. Let's go ahead, project the next one, and then we'll rock and roll. Okay. Sorry. Yeah. So problem C. So problem C, unlike problem A, also doesn't have both x and y variables. So in this case, we're going to solve for the only variable that we see, which in this case is y. So let me go ahead, speak to myself. Solve for y. So if you're not with the y, you gotta go. Let's isolate the y term by subtracting 3 from both sides, and that will leave us with 2y equals negative 7. To finish it off, to get rid of the times 2, let's go ahead divide both sides by 2, and that will give us y equals any equivalent form of -7/2. With your permission, we'll write it as a decimal. So that's 3.5 or 3.5 negative. Fantastic. So again, it would be really nice if I can just look at the equation and be like, bam, this is what the graph should look like. But again, when you're rusty, you're rusty. Okay, so we are going to go ahead do a table of values to help us organize identifying or ordered pair solutions or points that are on the line. Now, our equation reads y equals -3.5. Y equals -3.5. So there's no way around it. Y has to equal -3.5 or that's it. Okay, so let's go ahead and speak to ourselves. Has to equal -3.5. Okay, so the value of y is locked in at -3.5. So in this case, we're gonna pick random values of x. So any x from -5 to 5, but why make it more difficult? Let's pick 0. So when x is 0, the procedure says substitute a 0 for x and then solve for y. There is no there's no x, and y is still -3.5. So just like that, we have found our first ordered pair solution or our first point on the line. Okay, so from the origin, x is 0, so we're going to stay put. Y is -3.5, so we're going to go ahead, go 3.5 units down. So just estimate it. Am I going to be like, oh no, that looks like 3.4 negative? No one's going to know. Okay, let's pick another, y is locked in. Let's go ahead, pick another x value. Let's go ahead, pick what? So when x is what? Procedure, substitute a 1 for x and solve for y. But again, there is no x and y is still -3.5. So we have 1, -3.5. Let's go ahead, graph this with confidence. Okay, so we go 1 to the right and then go 3.5 units down. And then if we use our imagination, looks like we're going to have a horizontal line. So let me go ahead, take the straight edge so I can connect the points. Fantastic. Okay, so now I'm gonna go ahead and try to project all three equations. Oh, sorry, I'm having a technical difficulties here. If you saw a picture of my writing area, it's not that large. Okay. Okay, that's it. It's not happening. Okay, I tried my best. Okay, so what I want to point out is the following. So if your equation has both x and y variables, then your graph is going to be slanted somehow. It could go up, it could go down, it could be really steep or not so steep, whatever. But what I want to point out is this. If your equation has both x and y variables, we should have a slanted line. If your equation doesn't have both x and y variables, then guess what? We are not going to be slanted. Those slanted lines are reserved only for equations that have both x and y variables. So I say this to add to our number sense. Number sense is just code for feeling comfortable with numbers. Okay, if your equation only has an x only, you're going to have a vertical line. Okay, that's how it's written in your books. Okay, so in this case, we have x equals 2.5, and it's like, okay, x only, vertical line. X has to equal 2.5, so we have a vertical line that should cut through 2.5 on the x-axis, or that should go through 2.5 on the x-axis. What if your equation only has a y though? Okay, if your equation only has a y only, as you guessed it, horizontal line. And if you didn't want to do a table of values, you can be like, oh, y only, horizontal line. Y equals -3.5. Well, guess what? My horizontal line has to go through -3.5 on the y-axis. Cool, fantastic. So this is the end of this video. In the next video, I'm going to show you another technique. And in the third video, you guessed it, I'm going to show you a third and final technique. And then you pick your favorite technique to graph these bad boys. Thanks.